Good morning one and all. Today I am discussing about the fluid mechanics and hydraulic machinery laboratory 18CVL48 for 4th semester students under module 1 of laboratory class lecture 1 calibration of V-notch to find the coefficient of discharge CD. So the aim of the experiment is to determine the coefficient of discharge through V-notch. The operators used are V-notch collection tank. So this is the V-notch and this is the collection tank, and this is the head causing the flow and measuring scale and stopwatch. So isometric view of that one, pictorial representation of V-notch is shown, where this is B and this is H and this head of the water. This is H1 and this is the water level at final level H2. This is theta, angle between the two lines of an vertex. So now when we take a diagrammatic representation of V-notch, we will have two buffer valves and there is a constant head supply of water will be there at this end, and it will be regulated by using a regulatory valve here. And so the head which causes the flow over this particular height, so will be measured. So and the measurement volume of the tank and rise of the water will be measured by using the piezometric head. As I said earlier, this is H1 and this is H2, and this is a hook which measures the path traced by the projectile of the water. So the theory is a V-notch is a commonly used for the measurement of small discharge in an open channel. A V-notch is the shape of a triangle, so with its apex down and base at the top. The stream of liquid is called as a nappy, that is whatever flow here nappy. The nappy should be fully ventilated so that the pressure below is atmospheric pressure. And the formula which is used to calculate coefficient of discharge is given by formula CD is equal to Q actual divided by Q theoretical. Q actual is equal to the A into H divided by T, where A is the area of the collecting tank, where H is the rise of water level, so in the tank. So rise of the water level in the tank, that is this line, piezometric rise, and for a time interval T in seconds. Theoretical discharge is given by formula 8 by 15 root of 2g tan theta by 2 h whole to the power of 5 by 2, where the g is acceleration due to gravity 9.81 meters square per second. We have to take theta is the vertex angle. So that is, in this case we are measured so in our laboratory and it was found to be 45 degree. So and h is the difference of head, that is from here to here is H1, from here to the water flow level is H2. The difference will gives the H value. Coming to the procedure, so measure the, as I said earlier, step 1 is apex angle, you have to measure it. So open the supply valve and record the hook gauge reading, and when just water start enter here, so here there will be a hook gauge, you record it. Then once the water will come to a steady state, again record the hook gauge reading. In the meantime, tank dimension you have to measure it, and initial height, piezometric height, and at a constant time interval, or to get a height of 10 mm, what is the time taken, that you have to record it. Both are vice versa. And by regulating the flow, we can calculate for 10 mm rise in the tank what time it takes for second, third, fourth readings. Okay, so that completes that experimental part. Coming to the calculation, observation is, as I said earlier, V-notch apex angle is 45 degree. Dimension of the tank, this tank is 40 × 10⁻² meter length, 43.5 × 10⁻² meter is the width, area is 0.174 meter square. First trial, initial height H1, this is constant from this steel platform to V top, that is 0.074, and final height is 0.096 for trial 1. The difference will be 0.022 meter and h to the power of 5 by 2. Because of theoretical calculation purpose, we are using this column. That value is 7.7 10 to the power of minus 5. Q theoretical, as I said earlier, that is 8 by 15 root 2g tan theta by 2 h to the power of 5 by 2. If you calculate it, it is 7.015 10 to the power of minus 5. Rise in the water in the measuring tank. So this is the rise in the water. We kept it as a constant, or time can be kept constant and this can be vary. So but we kept it tank height as a water level prism height as a constant. For the time taken is 36.5 seconds because the flow was slow. So and Q actual is A into H divided by T is 4.76 10 to the power of minus 5 meter cube per second. And if you calculate theoretical versus the actual versus theoretical, the CD is 0.67. Similarly, for in the that is for 25% opening of valve to the 50%, time taken will be less. For 10 mm rise, for again for 75%, time taken will be further get reduced to 6.1 seconds. Again for 100% valve opening, quickly flow take place up to this end, and therefore the time taken will be less, 5.6 seconds. So the average of all these CD values, so for one is full valve open, another one is 75% valve open, so that is 25% valve open, and that is full valve open, 75% open, 50% open and 25% open. As the valve opening get reduces, time taken to fill the tank will also get increases. Therefore, at all four critical conditions we are testing, and therefore CD will be around 0.73. Now to validate this value of the theoretical approach with graphical approach, a Q theoretical on x-axis versus Q actual on y-axis, a graph is plotted by considering x-axis, y-axis, 2 unit is equal to 10 to the power of 1 into 10 to the power of minus 4 meter cube per second. We will get a straight line graph, the slope of the straight line. So any two constant values on x-axis, you can take corresponding y-axis intersect, that is AB by BC I taken, it will be 0.75. So theoretically that is the experimentally what we got it 0.73 average, and graphically also 0.75 we got it. So now you record all these values here, theoretical value of coefficient of discharge and graphical value of coefficient of discharge. That ends with the results of the particular Wiener experiment. Now coming to the MCQ questions. So first question is the actual discharge for calculating the calculation of coefficient of discharge using V naught is given by A into H divided by T meter cube per second. Whether this formula is true or false, the formula is true. That is option is A. Second question, actual discharge for calculation of CD in V naught is given by Q actual is equal to A into T divided by H meter cube per second. As H should be on the NR, it is in the NR, therefore it is answer B, false. Theoretical discharge for calculation of coefficient of discharge using V naught is given by formula Q theoretical is equal to 8 by 15 root 2g tan theta by 2 H whole is 5 by 2 meter cube second. This is a correct formula, therefore answer is A. So fourth question, theoretical discharge for calculation of CD using V naught is given by 7 by 15. So that is it should be 8 by 15, therefore it is B, false. Similarly, fifth question, theoretical discharge is given by formula, they are given the 8 by 15, they are given 2g tan whole to the power of 4 T2 they are given, therefore it is wrong, that is answer is false, B. Similarly for sixth question, so here 8 by 15 2g correct, tan whole to the power is correct, H by 26 by 2 is given, therefore B, it is false. Theoretical discharge for calculation of CD using V naught is given by here also, so 5g is given, it is 2g, therefore it is false. So small variations will lead to confusion, but we should be very careful when we are answering MCQ question. theoretical discharge for calculation of CD in V naught is given by 8 by 15 to 10 whole to the power of 5 by 2. So here, so the answer is correct A. Coefficient of discharge for calculating CD using V naught is given by CD is equal to Q actual by Q theoretical. It is correct. But his answer is A. 10th question, same question, but Q theoretical by actual, then it is false. B. So I take this opportunity to thank Department of Collegiate and Technical Education for giving me an opportunity to deliver lecture related to fluid mechanics and hydraulic machinery, laboratory, so related laboratory experiment. And also I take this opportunity to thank the students for attending the class. If you have any doubt, you can feel free to ask. Thank you very much.